Alright, example 2c, what we did is you multiplied a difference of squares, and you had a 2 minus and a 2 plus, and so what you get, those are actually called complex conjugates. And conjugates are super nice. Is where you have the first two numbers are the same, the second two terms, or two numbers of the term are the same, but one's a plus, one's a minus. So here, for example 3, you need to multiply each complex number by its complex conjugate. So if we look at 3a, if you have a 3 plus I, the complex conjugate would be a 3 minus I. So all you're doing is just changing the middle sign. You're not changing the 3, just the i's are changing. Now the reason you do that is because then when you do a difference of squares, when you multiply these, 3 times 3 is 3 squared, put in the minus sign, and then you have to multiply I times I is an I squared. Then that gives you a 9 minus I squared, which is really 9 minus negative 1, which gives you a 9 plus 1, which is 10. So the nice thing about multiplying by a complex conjugate is you get rid of your i's, which could hurt in some cases. So if you have 5 minus 6i for part B, then the complex conjugate of that is going to end up giving you a 5 plus 6i. So you're going to take the, once again, you're going to take the 5, square that, and then you're going to take the 6i's, and you're going to multiply those because you're going to square those. So you're going to have a 6i squared. And when you simplify these, this is going to give you 25 minus 36i squared. If you have an I squared, you just mark that out and make this a plus. So 25 plus 36 gives you the answer of 51. Sorry, 61. There are those that can add and those that can't. I sometimes can. So there's 61. No eyes. No eyes, just like the fish.